Okay, so I have a lot of people to thank. I'm going to start with the funding that has been supporting this research program since at least 40 years at this point, both the California Pistachio Board and at this moment the UCE endowed presidential chair for Tree Nut Genetic that is helping me to do the work that I'm doing since 2 years from now. And Patrick J. Brown, the breeder at UC Davis, that is my partner, and we're working together in all the project that I'm going to present. And of course, Craig Carlsen, Dan Parfit, and Joe Maranto that started the breeding program long time ago. And we have to thank them not only for all the cultivar that we are now growing, and also for all the material that I am now evaluating that wouldn't be there if it wouldn't be for their amazing work in these years. I also want to thank all the growers, since most of the cultivar evaluation trial and rootstock evaluation trials are in grower orchards. So without your help, we wouldn't be able to do all what we're doing. And I figured this out. Okay, first part of the presentation, I'm going to talk about a little bit of comparative information about the commercial cultivar that we're cultivating now, that come from the previous work of the breeding program, and then I will give an update in the second part about the current and future activity of our evaluation program. The genetic material that is described in the second part is still under evaluation, so it's not commercially available for the industry, and it will take time for this to be available. So just presenting this as informative. This slide shows how the acreage, the increase, the expansion of the pistachio industry, and in comparison, it shows the expansion of the biodiversity or the diversity in terms of cultivar and rootstocks that we have. So producing new cultivar and rootstocks takes a lot of time. They have to be evaluated several years before they have to start to produce. So the breeding program really started in the 90s. And only at the end of around 2008, we had the first new cultivars, and then in 2016, gumdrop. At the same time, for the rootstocks, we have basically like no changes. We structured our industry with the Kerman on UCB1 in the 90s, and we've been going with this since only recently, when thanks to micropropagation, we're able to have some clonal rootstocks. But we're still speaking about the same species, Integerrima with Atlantica. So we don't have a lot of biodiversity in terms of rootstocks. At the same time, other factors, abiotic and biotic stress, as Steve showed before, are impacting and changing and challenging the industry. So drought, heat, sigma, reduction of water, and new pests, and so on. So the objective of the breeding program had changed with the times. So where in the past, one of the first objectives was really to expand the harvest time. Having only Kerman, it was okay when the industry was smaller, and when we started to need more cultivar to be able to spread the harvest over a longer period. So this is the first part, and at the same time, we wanted, of course, always high-yielding cultivar with high quality and with reduced alternate bearing. I'll start with the past, and I can show how we achieved this thanks to the release of Golden Hill, Lost Hill, and Gumdrop. Now we're able to extend the bloom timing and the harvest time up to 1 month. So we can see Gumdrop is the first blooming and the first being harvested, followed by Golden Hill and Lost Hill, and Kerman is a later cultivar. So now we have this possibility to spread our harvest calendar on a larger period. What is most important is what we differentiate also the time of bloom. As we saw in the last year, it happened, I think it was 2 years ago, that there was a heat spell during bloom. Having two cultivar helped us to have at least half of our orchard that was not impacted by the heat spell because it bloomed 1 week earlier or 1 week later. So this is a clear example of how important it is to diversify the production and not rely only on one genotype. Characteristic of this cultivar that has been released in the last years, you are probably familiar with some of this information, and I don't know why some boxes are missing at this point. Let me check. Well, that's okay. Golden Hill is the one with the most upright branching. This is useful. It can be planted at a smaller spacing, and it also is better for shaking. Kerman is the smoother graft union that helps in the grafting, better grafting. It's also the most vigorous, so requires more pruning effort than the others. Gumdrop has showed in some of our trial to be a little bit of an earlier yielder, so it has a little bit of more yield at the beginning. Eventually, in the long term, we didn't find a clear pattern, at least in our trials. These are like research trial with more replication of yield. The more or less the final cumulative yield is variable, the results, they're similar. Alternate bearing, it's very interesting because low still is the least alternate bearing cultivar, and gumdrop is the one that shows the highest tendency to alternate. And here you can see an example of this with the beginning of like alternate, so you can see the onset of alternate bearing happening in Kerman and Golden Hill at one point of the production cycles, and the low still cultivar maintaining a more stable yield from year to the other. This can be an advantage because it allows you to have higher yield when maybe most of the other people have lower. Gumdrop, we're starting to be familiar, is the last release. This is the typical cluster of gumdrop, very heavy cluster, compact, and this, when heavily produced, when heavily loaded, they start to alternate more than the other cultivar. You can see the second year a little bit of higher yield in gumdrop, but then eventually it just becomes similar to the other, but it has a tendency to more pronounced bearing cycles from one year to the other. Yeah, I don't know why like there were balls in each box and they disappeared. I'm sorry about that, but just summarizing the nut quality characteristic, Kerman tend to have a lower in shell split percentage than the other, so they go a little bit higher, above 80, and Kerman is a little bit lower, around 70 and something. Low still has the characteristic to have more loose shell and kernel. He has a less strength of the interaction between the two shells, so you're going to have more shells that open, and so higher percentage of loose shells and kernel. Kerman has higher blank with respect to the other cultivar, and one of the main advantages or good things of Golden Hill that is good if we are very good in planning harvest is that it ripens more homogeneously within a tree. So you can see here the ripening patterns of Golden Hill and Kerman. This is been presented and published by Jacqueline Agaskavich in last year in the Pistachio conference, and she was like a graduate student in Barbara Blanco lab. And you can see this graph shows the textures, the texture of the hull. So the higher the value, the more firm, and as it goes down, the hull becomes softer. So it's basically a proxy of ripening, a harvest readiness. And you can see that basically Kerman is more forgiving us, so it's more smooth, the decline or the breakdown of the hull, while Golden Hill, basically, from 1 week to the other, these data are taken weekly, and you can see on top, just after the 15th of August, there is 50% of decline of the hull texture. That shows how fast Golden Hill ripens, so timing harvest is very important, but at the same time, if well-timed harvest, if it was not a low chill year, which can spread the ripening, then you could get Golden Hill with one single shake. Okay, so this overview was about like the first round, so this first round of selection of cultivar that was done for earlier harvest to extend the harvest season. As I said at the beginning, there are new challenges that are becoming more and more issues for the production that are challenging us. One of these is the chill requirement, or the increase in temperature during winter, for both male and female. So this has been also a focus of the breeding program and of the evaluation program. So we're going to focus on this as a first. What happens if there is a low chill? One of the most impactful effect of low chill in pistachio is the asynchrony between females and males cultivar. So it seems that basically they are affected differently because they have different chill requirement. So 2014, 2015, this is like a publication also from Craig and Dan and Joe, and these 2 years were very low chill. And what happened, the female cultivar was always going 5 to 6 days before the male. So this is common, it happened in all the cultivars, you can see, gumdrop and tejon. So mismatch of bloom, no pollination, low yield, and this has been one of the big issues associated with low chill, sorry. So in the last year, one of the suggestions has been to use not, if you are in an area that you think is low chill because of the location, or is going to be low chill in the next 10, 20, 30 years, the suggestion is to use more than one male. So have some early male, so in this year you can have more covering of the female flowering with more pollen available. We have one selection that has been under evaluation now for 9 years, that in a location that is with low chill. And this location is a little bit even a hill, so it's not receiving that cold during the winter, and the chill hours are less in this location. And this new advanced selection has been producing more than, in this case, I don't know if you can read it well, but is their pink line with respect to Kerman and Lostil has been producing more every year since basically 9 years ago, started to produce in 2016. On the left, you can see the yield per acre, and on the right is the cumulative yield over 9 years. So this has been one of the selections made in the past by Craig and Dan, and we're continuing the evaluation of this cultivar, potentially working on its release in the next years. This new cultivar, or potentially new cultivar, blooming is interesting because it goes a little bit earlier than Lostil and Golden Hill, but it gets harvested a little bit later than them. So it fills that hole between gumdrops and Lostil, Golden Hill for the bloom, and a little bit later for the harvest, giving a larger time of growth for the nuts. So they bloom earlier and they get harvested later, so they have more time. Another interesting trial that has been planted, like I think it was in 2017 or 16, is an experimental orchard that Dan and Craig planted in Coachella. So if you are basically like in a place, they wanted to see what would have been the behavior of pistachio under basically no chill. These are the conditions in the area. So the thermal is the semi-station closer to this research site, and the Jasmine is the low chill location in Kern County. So you can see basically we have 1.8 times less chill hours, or hours below 45 degrees in winter. We have 3.5 more heat hours during winter, or hours above 65. We have 2.4 less chill portion, so the average chill portion was 28 chill portion. So if you are familiar with the requirement for pistachio, this is very low. But what was most surprising was this: 26 times more heat during bloom, which we think in that condition was the most limiting factor. In addition to the low chill, the heat was terrible during the bloom timing. So basically like very, very hot during bloom. What happened to pistachio under no low chill condition or zero chill condition? What we observed is that there is like a lot of the rootstocks doesn't go dormant. So there is a huge overgrown of the rootstocks that has to be suckered continuously. The rootstocks have the integerrima, which is like from low chill areas. So basically, like it doesn't go dormant and continues to produce suckers while the scion is dormant. And then you have this hugely uneven bloom. You can see one of the cultivars with just few branches producing leaves, and the rest is still dormant. So very high uneven bloom in the genotypes. We went there last year, 21st of April. All the Central Valley was already blooming and leaf were expanded, and none of the commercial cultivar had pushed still. They were basically without leaves and without flowers. On the contrary, some of our selection that have been planted there, at the same time were showing leaves and also some buds, and they were already developed leaves and flowers. So this shows the better adaptation of this selection under this extreme condition. This is another way to look at the low chill requirement of these genotypes that we are selecting in this moment. This is the classical method to evaluate what is the chill requirement of a cultivar. So what we do, we go in winter, we take sticks with buds, and we put them in a grow chamber and we force them to bloom. So we simulate spring. So if the bud flower, it means that the chill requirement was satisfied. Okay? And here you can see the pink line in the bottom is Golden Hill. And in comparison with the other, this new cultivar, this new hybrid that we're evaluating, in the bottom is the day that they stayed in the grow chamber, and the bloom percentage is on the left. So you can see how basically like at the beginning of February, Golden Hill was not blooming at all. It was just not producing any flowers, while all the hybrids after 10 days were having more than 50% of the bud flowering. So it shows that how low was the chill requirement of this new selection. And at the beginning of March, that was just incredibly, the difference was even more. So Golden Hill, no bloom, you can see the pink line staying there and not moving, and all the hybrids basically after 5 days in the grow chamber had 100% of the bud that had opened. So we're evaluating these genotypes, and the best one are going to be planted in the next years in a bigger evaluation trial in Kern County or in the area. Another aspect that has been studied in the last year by our group is the salinity tolerance. We have been heard by May about the salinity and how these affect productivity. And Rootstocks in general is one of the first tools that we have to fight against soil issues like salinity or low water. So there are some rootstock selections that have been selected again by Dan and by Craig in the last years that are selective to boron. So they don't let the boron go up in the leaves. So you can see the leaves of Golden Hill on UCB1, basically in the same, so they were on the UCB1 and in our experimental rootstock. On UCB1, the boron in the leaves was around 2000 ppm. In the experimental rootstocks, it was only 500 to 1,000. So half the concentration of boron in the leaves. And you can also see this in the pictures very visually. Since the boron toxicity is very clear, you can see the margin of the leaves burned. In addition to the data, you can observe how different were the leaves, despite the trees were in the same condition. These rootstocks have been producing same yield as UCB1 for several years. This has been evaluated by Craig and Dan, and we're continuing to take data on these rootstocks. The only problem is that at the moment they are seedlings, so to be able to compare them, we need to micropropagate them. So this is something that our group has been doing in the last 2 years, and we thought it was going to be easier, but it was not so easy as expected. So the protocol for micropropagation that we have been developed, all of them for UCB1, and these rootstocks are different, and so they need different protocol. So I have to thank Franklin Lewis. He is like an assistant specialist at the Department of Plant Science, and is the micropropagator, and he has been doing a huge work in the last year trying to develop a new protocol for propagating these new rootstocks. We did the introduction in vitro in 2023, and then we had to change the media to make them multiply. We had problem with the rooting because they were having necrosis, so it's testing a new way to have this rootstock rooting. And now we are starting to have them in the greenhouse, so hopefully we're going to be able to plant rootstock evaluation trials with commercial rootstock in the next years. I have to say pistachio is generally very recalcitrant to root. Any species of pistachio is very difficult. So, but this is what we have been working in the last 2 years. Another things that I wanted to, I'm gonna skip about like less susceptible. We're working also on some cultivar that are less susceptible to navel orange worm damage, but I'm skipping on this for lack of time, and I'm gonna I'll introduce a little bit of some work that we're doing. We started last year to look at nut and kernel quality. Because so far we've been focusing more in split, in shell split, and edible weight, but maybe in the future there are going to be other quality traits that are going to be important to maximize income in our pistachio production. So we're starting to look at the impact of different genetics on kernel quality. And one experiment that we started last year looks at the impact of pollen on pistachio quality. So the question is, does the male, apart from having to overlap the bloom, is there an effect on quality of the nuts? This was very like a first year, so we tried 9 males, the commercial and some that are unreleased. And we found that overall the male impacted all the quality parameter that we look. So it's very preliminary, it's very interesting. So this is pushing our curiosity into looking at the males that are available in the germoplants collection and see if there is any of these males that can have a positive impact on some quality traits that the industry could be interested, because it's a very overlooked process. So the next step that we're going to do is going to work on this low-chill cultivar release and taking more years of data if needed, but this has been already evaluated for several years, so it's at the final steps of the process. For all the rest, we are still ahead, at the beginning of the process, sorry, not ahead. So objective are to plant a new plot with the best low-chill hybrid that I was showing before. So we're going to select them and plant them and evaluate them for yield. We're going to continue to improve the micropropagation protocol for the rootstocks and plant rootstock comparison trial of our rootstocks with a commercial one. We're going to work on the yield assessment of some genotypes that have tied hull. They maintain the hull tied until the end of the season. That could help with navel orange worm susceptibility to reduce it. Male selection for improved quality. This is something that we would like to look at as well. And something that also we didn't check so far is like what is the drought tolerance of all the, we have a lot of genotypes that have never been screened for drought tolerance. So this is something that we will start to do in the next year, starting with looking at traits for drought tolerance and then potentially doing some like trial where we irrigate them less and see how the performance are affected under lower water application. I have to thank Craig and Dan, not only for all the work and all this genetic diversity that we are inheriting thanks to them, but also for their guidance. They've been available to help me in these years all the time that I needed and gave me support. So thanks to both of them. Thanks to Paula Guzman Delgado, that is the co-PI in the lab and just doing everything with me in any aspect of the research program. Louis Ferguson for being a mentor in these years and always giving me support. Patrick, who is going to work with me hopefully in the next years on this. We are working with Pat in all these aspects as well together. All my lab and the collaborators and all the growers and the board that has been supporting us. And there are 5 minutes, and I don't know how I was so much in time. I'm surprised.